Let's follow the ASIL here, which we the safety goal here, which we have defined as prevent activation of steering lock while driving, and it receives an ASIL D rating because it is assigned also to a hazardous event that has an ASIL D as the result of the analysis. Okay, so we can go for this one and see this in another editor. This now is our safety goals and safety requirements editor. You can use this graphical view for these. You can also choose to have a tabular form or tabular editor that is also available. So different notations, different editors for the different elements. Let me quickly open it. Safety goals or safety requirements list editor, and then it has not this graphical form, but it still provides you with the details of the relations of the refinements, and comes then with additional properties that are then defined and shown and presented to the user in this tabular format. Recoil. So based on this very generic concept or idea, right, we start at the same time as we refine the safety requirements, we also start to develop what we call a functional safety architecture. That's here. That's again now it's a refinement of our very initial item architecture, right? We know a little more now. We start to develop our or to allocate our safety requirements here. For example, our controller here has a number of safety requirements allocated. For example, here detect vehicle state based on speed. Each of our malfunctions that we define here, we can now set into relation, right? We can open what we call a failure net, yeah, and you will see here that our no ignition state information as a malfunction might lead into a malfunction of the lock steering function, that is locks when not required, and the other here is it might lead into a malfunction unlocks when not required in our unlock steering function. If I want, I can also use this instead of failure, I can also say I want to derive, here, I want to derive an FMEA worksheet, right? That's then a normal FMEA worksheet that you might know from FMEA tools or from Excel, right? That has all the columns for the failures, for the failure causes, for the failure effects, and other columns depending on the FMEA worksheet layout that you have chosen for this particular FMEA exercise. So after finishing my functional safety architecture, my functional safety concept, right, I'm now diving into the technical implementation of my electronic steering lock, right? So I'm creating what is called a technical safety architecture and a technical safety concept, right? So I'm now providing technical solutions for each of my requirements that are at this level. Actually, you would start to distinguish between between a hardware safety architecture and a software safety architecture. Okay, so let's have a look into the software safety architecture first. Okay, yeah, we are right here. Okay, so I'm saying I have my software architecture in terms of software modules. The software modules are connected to elements in my technical safety architecture. In particular, they are connected to the ports which provide information or which are supposed to send information, right? Again, here I can say I want to derive an FMEA, which then would result into a software FMEA, right? And I would have my software basic actions, my potential failures, and I could start to add also effects and causes. If we look on the other side in more details into the hardware safety architecture, right, that we will find here, we basically at this point would not use diagrams anymore because number of elements for the hardware safety architecture might be very, very high, right? So we use tables, which is in fact invalid notation for system models in our thinking. So we have components here, like we have maybe we look into the micro, and in the micro we will have this Aurix line right here. Okay, so we have a line for an element called MCU1. That's the first micro in our technical safety architecture. This is of type Aurix, so I can predefine my types somewhere else and reuse them in my application, right? And from this definition of the type itself, we will inherit um, the um, the prediction mode, which in this case is IEC 62380. We will inherit also the failure modes, the failure rate distribution in percent to each of the failure modes, and then according to the raw failure rate and the failure rate, right? Um, with applying scaling expressions, right? We will come then to the failure fraction for each of the failure modes. If I have the bomb then in this sense somewhat set up, I can go ahead and say I want to derive a diagnostic coverage worksheet. That's the hardware DC matrix worksheet, right? In this example, that has already been done, so I can jump to that particular element in my project. Diagnostic coverage DC. Or yeah, my cover sheet actually allow me for a number of preset things for my analysis exercise. So I can, for example, say I want to analyze multiple safety goals in the same worksheet. I want or don't want to see ports and their failure modes, right? And then the worksheet looks like this. So it's actually listing up all the components from my bill of material. It would um, provide me with the failure rate. I can set the safe failure fraction if I have knowledge about that, and it allows me to say it violates or a failure mode violates my safety goal as a single point fault, or violates my safety goal as a latent fault, right? And then I can bring in my safety mechanisms, which again can be predefined, like you see here, in a library that can be shared between application projects, right? And then finally, it will calculate for me the single point fault and the latent fault metrics down here, okay, with the expectations and the actuals. This, by the way, can not only be done for permanent faults, but you can also include the so-called transient faults here, and then it would also calculate the transient fault metric for the single point transient faults and the latent transient faults. Since the last version of Medini, we also have something here that is called SM coverage. That means safety mechanism coverage. So you can decide to play around with the safety mechanisms. You can turn them on and off, assign them to your project, and then the worksheet will tell you with which of the minimal sets of safety mechanisms you can still achieve your target numbers for the metrics.